All right, so we are looking at things that are falling from the ground when gravity is at work. The pull of gravity is negative 32 feet per second, and that's an acceleration. If I'm interested in the velocity, that's going to be one antiderivative, so that's going to be negative 32t plus a constant, and we'll give it a special name v sub 0, where we say v naught, which means initial velocity. And if I take the antiderivative again, I get to the position function, and I see I get negative 16t squared plus v naught t plus another constant we're going to call it s sub 0, which means s naught. So that's if we have English units going on. If I have metric units going on, then the acceleration of gravity is negative 9.8, and we can do the antiderivative to get those same things. All right, so if I have something being dropped, that means the initial velocity is 0. If I have an object on the ground, that means its position is 0, and many times we'll be finding the time when it's on the ground. And when something is being thrown up, you need to assign it a positive velocity, and if it's being thrown down, you need to assign it a negative velocity. All right, so let's look at this first question here. So we're dropping something, silver dollar, off the top of this 1362 foot high building. And then we want to find the velocity when it hits the ground upon impact. So I'm going to suggest that you start with building with the acceleration of gravity, which is negative 32, since I've in English units. Take the antiderivative, negative 32t plus v naught. I know that is being dropped, so v naught is 0. So I get this as my velocity equation. So I take an antiderivative again to get the position function. I see that s naught is 1362, so this is my position function. So I've got my three functions, velocity, well, mostly I need my velocity and my position function. Now we're ready to answer the question. So the question is telling me they want me to find the velocity when it hits the ground. So when it hits the ground is just like I was saying, that's going to be when the position, so find t, when s of t equals 0. So that's going to be sitting negative 16t squared plus 1362 equals 0. So that gives me t equal plus or minus 13 is square root of 1362 over 16. I'm going to only take the positive time because that would make sense. And so that gives me approximately 9.2. So that's the time it hits the ground. So what's the velocity when it hits the ground? That's going to be, take the velocity function and use the time of 9.8 in there. So negative 32 times, plug in 9.2 into there. So multiplying, I get negative 295. It should be negative because velocity has direction. You could put units in there, feet per second, not necessary. All right, here we go, another one. So we've got a rock being thrown down at this 10 feet per second. So I see my acceleration is going to be negative 32. My velocity will be negative 32t minus a 10 because it's being thrown down. So I have to assign it a negative velocity. So then I want to find, let's see, if it hits the ground at 30 feet per second, find the height of the cliff. Okay, hits the ground at 30 feet per second. So that means when it hits the ground that I have a velocity of negative 30 feet per second. So I have my velocity equation. So let's set negative 32t minus 10 equal to negative 30 to find the time it hits the ground. So add over the 10, divide through by negative 32, so I get t is equal to 5/8. So that's the time it hits the ground. The time it hits the ground is time 5/8. Okay, so let's go find the position function. So the position function is negative 16t squared, minus, because I'm taking the antiderivative, so minus 10t plus the position, s sub 0. So I want to find, this is what I'm trying to find, is this s sub 0. So I know it hits the ground at 5/8 seconds, so that means s of 5/8 is equal to 0. So I'm going to set it equal to 0 and substitute in 5/8 for t. And then I'm going to solve for s sub 0. So I'm going to move everything to this side. So I'll get 16 times 25 over 64 plus 10 times 5/8 equaling S naught. So that will give me S naught is 25 over 4 plus another 25 over 4, so 50 over 4, or 25 halves. So that is the height of the cliff, that many feet.